Hello everyone. Today's topic is about bioremediation. Bioremediation is a biotechnical process. This presentation is made by Ahir. So what is the bioremediation? This is a new concept to all. Bioremediation is a biotechnical process which abates or clean up contamination. It is a type of waste management technique which involves the use of organisms to remove or utilize the pollutants from a polluted area. You can see the diagram in front of your computer screen. Infection to recovery, like oxygen and nutrients, carbon dioxide. So there are several remedies where contaminated water or solid is purified by chemical treatment, incineration and burial in a landfill. There are other types of waste management technique which include solid waste management, nuclear waste management, etc. Bioremediation is different as it uses no toxic chemicals. Microorganisms like bacteria and fungi are the main role player when it comes to executing the process of bioremediation. Bacteria are the most crucial microbes in this process as they break down the waste into nutrients and organic matter. Even though this is an efficient process of waste management, but bioremediation cannot destroy 100% contaminants. Bacteria can easily digest contaminants like chlorinated pesticides or clean oil spills, but microorganisms fail to destroy heavy metals like lead and cadmium. Next one is types of bioremediation. Bioremediation is of three types. Number one is biostimulation. As the name suggests, the bacteria is stimulated to initiate the process. The contaminated soil is first mixed with special nutrients, substances including other vital components, either in the form of liquid or gases. It stimulates the growth of microbes, thus resulting in efficient and quick removal of contaminants by microbes and other bacteria. Second one is bioaugmentation. At times, there are certain sites where microorganisms are required to extract the contaminants. Example, municipal wastewater. In these special cases, the process of bioaugmentation is used. There is only one major drawback in this process. It almost becomes impossible to control the growth of microorganisms in the process of removing the particular contaminant. Next is intrinsic bioremediation. The process of intrinsic bioremediation is most effective in the soil and water because of these two biomes, which always have a high probability of being full of contaminants and toxins. The process of intrinsic bioremediation is mostly used in underground places like underground petroleum tanks. In such place, it is difficult to detect a leakage and contaminants and toxins can find their way to enter through these leaks and contaminate the petrol. Thus, only microorganisms can remove the toxins and clean the tanks. Bioremediation of wastewater. The bioremediation of wastewater is an important part of bioremediation. The sewage water can be treated by the process of bioaugmentation and intrinsic bioremediation. The process is done with the help of microorganisms, which can be reached any part of the contaminated places like municipal water tanks. The aerobic microbes are used in these processes and the water is aerated to provide oxygen for the bacteria to thrive and grow. The bacteria consume the organic contaminants and mold the less soluble parts. The byproduct of this process is nitrogen gas, which is later released into the atmosphere. It is up to the situation or the availability of the resources that which one fits well. All of them have their unique attributes. Along with these, people have also explored a few more methods such as incineration, landfill burial, treatment with the use of chemicals, managing solid waste, managing nuclear waste, and more. If we talk about the pillars of bioremediation, then fungi and bacteria top of the chart. Bacteria are said to be the most important microbes for executing their entire process, as these help in breaking the waste material into organic and nutritional matters. Without this, it is considered that bioremediation will not be sufficient to kill pollutants completely. Similarly, bacteria can consume pollutants such as chlorinated pesticides. Phytoremediation. So, phytoremediation refers to the technologies that use plants to clean up the soil, air and water that have been contaminated by chemicals. But phytoremediation is usually applied to contaminated soil or water environments that are static. Some of the examples include the restoration of abundant metal mine workings and sites where phytochlorinated biphenyls have been dumped during the manufacture and mitigation of ongoing coal mine discharges, reducing the impact of contaminants in soils, water or air. Contaminants such as metal, pesticides, solvents, explosives and crude oil and its derivatives have been mitigated in phytoremediation projects worldwide. Many plants such as mustard plant, alpine pennygrass, hemp and pigweed have proven to be successful at hyper-accumulating contaminants at toxic waste sites. Not all plants can accumulate heavy metals or organic pollutants due to differences in the physiology of the plant. Even cultivars within the same species have varying abilities to accumulate pollutants. So, advantages. In principle, plants that engage in phytoremediation of toxic elements could be harvested, thus removing these elements from polluted site. The plants can be easily monitored. The possibility of the recovery and reuse of valuable metal by companies specializing in phytomining. It is potentially the least harmful method because it uses naturally occurring organisms and preserves the environment in a more natural state. It preserves the topsoil, maintaining the fertility of the soil. It increases soil health, yield, and plant phytochemicals. So, thank you very much.